So what do we actually do? Okay, so first, if we were a mining company, this is how we would proceed. We'd take the aluminium ore, which is just this rock that we know has aluminium in it. We grind it up into a fine powder, and that helps us to remove some of the impurities. So we first grind it up into a fine powder. Then we dissolve that powder in the sodium hydroxide, as I mentioned. And then this solution, once we've dissolved our powder in it, is filtered, and that removes the impurities. And most of those impurities are iron oxides, so they form insoluble iron hydroxide compounds. So most of these impurities are iron oxides, so we actually just want the aluminium oxide. The solution is acidified, and that precipitates out the aluminium hydroxide that forms. So when we put aluminium in sodium hydroxide, it forms aluminium hydroxide. And then we use acid to remove this, or to get it into solid form again. And then once we have the solid aluminium hydroxide, we filter it, and then we dehydrate it by heating it. Okay, so we get this to precipitate out, becomes a solid. We filter it out, and once we have it, we heat it, and we get back to aluminium oxide. So this is now pure aluminium oxide. There's nothing else in it. There's no impurities, it's just aluminium and oxygen. Okay, and now all we need to do is just get the aluminium out of this compound. So we dissolve this aluminium oxide in molten cryolite, which is sodium aluminium fluoride, hexafluoride. That's at 1,000 degrees Celsius, so it's very, very high temperature. And at that very high temperature, we use electrolysis using graphite or carbon anodes and an iron tank cathode. So the anode is the positive electrode, and the iron cathode is the negative electrode. So connected to essentially the power source. This one's the positive one, this one's the negative one, okay? So liquid aluminium forms at the cathode, so in the iron tank, and it sinks to the bottom of this compound, and then you kind of just open up a valve, and then the aluminium leaves, and we can run it into molds, okay? So other than mechanical separation, what purpose does grinding the aluminium ore achieve? So other than being able to separate some of the impurities straight away, why do we grind it, okay? Well, grinding allows the ore to have a greater surface area that's exposed. So for instance, when you grind something, there's a lot more surface area because the particles are now separated. This helps to speed up the reaction between the NaOH and the Al2O3. For instance, if you took a lump of aluminium oxide and put it in sodium hydroxide, you'd have to wait till the outer layers shed away, slowly working your way inwards. Whereas if you took the powdered form, there'd be so much surface area, so much surface exposed, that it would react so fast compared to the big chunk. So that's why we grind it, just to speed up the reaction. Because business, time is money and all that. We want to speed up this reaction as much as possible. So basically all it does is it improves the rate of aluminium production. Okay. Lastly, the aluminium oxide within the bauxite ore is treated with several chemicals, then converted back to aluminium oxide before electrolysis. Why are all these extra steps necessary? So before we even got to the electrolysis stage, which was the most energy intensive stage, we had to go through all these other chemical processing stages where we dissolved it in NaOH, then acidified it, and then heated it, and then got aluminium oxide back. So we started with aluminium oxide plus some impurities, and then we ended up with aluminium oxide. And then after a lot of energy went in, we got aluminium. So why did we need to go to aluminium oxide? Why didn't we just go straight from bauxite to electrolysis? The bauxite contains lots of impurities, and that can actually interfere with your electrolysis, okay? So those impurities can actually interfere with the reactions happening in your electrolysis step. So by using all those other chemical processes, we remove the impurities first, and that ensures that only pure aluminium is produced by the electrolytic process, okay? So all we're doing is ensuring that all we're getting out is aluminium by putting in only aluminium oxide, okay? And that's why all of those steps are necessary. Otherwise, you'll get interference and you'll get contaminants within your electrolytic cell.